Zero product property, the technical way that it is said is if A times B equals 0, then either A equals 0 or B equals 0 or both, okay? So it says the product of factors is 0 if and only if one or more of the factors is 0. Okay, so that means one of them has to be 0 for it to, if you multiply it, to be 0, because 0 times anything is 0. Okay, well, this gets particularly helpful when solving quadratic equations, because I want you guys to type it to me. What's another word for solution? So if we were trying to find the solution to a quadratic equation, what's another word for solution? 0. Okay, Dalen, but think about the quadratics specifically, the things we talked about all year long, and I've been like, this is the same thing as, this is the same thing as. So I got 1, it's 0. What's the other words? Not product. Product means multiplying two things. We just reviewed it. Okay, remember solution, 0. Roots, yep. And then all of those are the same thing as, waiting for it in the chat. X what? I got an X, but it's X what? X intercept, yep. So that we have to know this property, and we have to know these all mean the same thing, because if we're finding the solution or the answer, yes, that it technically is an answer, but you have to think beyond answer now. We're thinking bigger, harder math, okay? So now we have to think that we're looking at the zero product property, okay? And that helps us to find the solution to a quadratic equation, or the answer. So the answer to a quadratic equation is our 0, our root, our x-intercept, solution, okay? So they all mean the same thing, okay? So now, keeping that in mind, here's how we can find the answers to zero product property questions, okay? So you're gonna have they look two different ways. So you could have ones that look like this, that say solve for x, okay? So if we were to solve for x on this, then zero product property says that since it's equal to 0, that means that either x plus 6 equals 0, x plus 4 equals 0, or both. Okay, so what the zero product property lets us do is find two different x values that will make this true, that will make this 0. Okay, so what you do is you take the first factor and the second factor and you set them each equal to 0. So we would take x plus 6 equals 0, and then we have to solve that. Okay, so I'm going to subtract 6 from both sides. That goes away. Remember, trying to get x on one side, numbers on the other, letters on one side, numbers on the other. Okay, and then I get x equals, I want that in blue. X equals -6. Okay, so that's one option. That's one solution. That's literally it. Now, if you downloaded the TI Inspire thing and you were trying, like you were wanting to use InSolve or something, then you technically could have used InSolve for this, but I hope you know how to do that without InSolve, especially because next year you don't get InSolve. So hopefully you knew to subtract 6. Okay, so that's one option. That's one possible solution. So then our other possible solution is for us to take x plus 4 and set it equal to 0. So then I'm going to subtract 4. Remember, it's the opposite sign. So if it would have been -4 or -4, then we would have made it +4. Okay, so then I'm going to cancel out those 4s, and I'm left with x equals -4. Okay, so those are our two solutions to this quadratic equation. And that's it. There's a whole, like, you got 4 questions that are over zero product property. And they're either going to look like this, or they're going to look like the one I'm about to show you. But this is literally it. Okay, so if you said which is the smaller x, well, -6 is smaller. So you would say -6. And then it says the larger x, well, -4 is larger. So you would write -4. Okay, so find the zeros. This is the other way that it'd be worded. Okay, so it's either solve for x or find the zeros. Okay, so zeros, again, are our solutions. And so to find a solution, we would set it equal to 0 because we want to find the x-intercepts. And all x-intercepts have a y, remember that's the same thing as y, of 0. So it's almost like we're going to say 0 equals negative 4x minus 5 times negative x plus 5. Okay, because all x-intercepts, and x-intercepts are solutions or zeros. Okay, that's why these words are important for us to know that they're all the same thing. They're all synonyms. Okay, so if an x-intercept is a 0, then that means all x-intercepts have a y of 0. So that's why I changed this to a 0. And now that that's changed to a 0, to find the zeros, all I have to do is set each one equal to 0, just like we just did. So negative 4x minus 5 equals 0. And negative x plus 5 equals 0. All right, so we're going to first get letters on one side, numbers on the other. So that constant, that negative 5, I'm going to send that to the other side. So it's a negative 5, so I'm going to add 5. And that's gone. And so then I'm left with negative 4x equals 0 plus 5 is just positive 5. But is x by itself? Nope. So we're not done. Okay, so now I need to divide by negative 4. Those go away, and I'm just left with x equals, and you could do the decimal of that, but there's no point. Just leave it as negative 5 over 4. So that's one possible solution. And don't tell me I didn't do a hard one when you get to these, because I tried to pick one that I knew would be a fraction. So if you guys had an example of fractions. Okay. Now try to get the other one. Yes, Caden's got it. Okay, cool. So it would be, there's a positive 5 that we need to send to the other side. Positive 5, so I'm going to subtract 5. But here's the thing, this is where most students stop on ones that look like this, because 0 minus 5 is negative 5. Most students stop here because you think the x is by itself, but that x is not by itself. There's an invisible what in front of that? What's in front of that? That's not just a 1x, that's a what kind of x? Yeah, there's a negative 1 there, and I have to get rid of negative 1s. Those aren't just a 1 and just an x by itself. There's that negative sign. We have to get rid of that. So we're going to divide by negative 1. And so then we get x equals negative 5 divided by negative 1 is positive 5. Okay, so now in this one that look like this, it's again going to say what's the smaller solution, or smaller 0, or smaller x-intercept, and the bigger one. So remember, it could be any word. Okay, so the smaller one is going to be your negative number. So this guy is smaller, right? And then your bigger one would be this positive number. Okay, and so that's literally the zero product property. That's it. Any questions before we move on to word problems? This is your, like I said, this is your second section of stuff today, or of this week. 4 problems that look just like these. Any questions? Okay. All right, so let's look at word problems. Okay, so we have a hovercraft takes off from a platform. Its height in meters, x seconds after takeoff, is modeled by h of x equals negative x minus 11 times x plus 3. What is the height of the hovercraft at the time of takeoff? Okay, so remember, word problems. First things first, find your important information. Okay, so it takes off from a platform. So its height is this h of x. That's what it's saying, and it's in meters. Okay, and then we have x is seconds. Okay, then we have our whole equation, and then it says, what is the height at the time of takeoff? What is the height at the time of takeoff. So time is it says x is seconds. So this is saying when x is what? What would be the time? What seconds would happen at takeoff? How many seconds have gone by at takeoff? 0 seconds have gone by because it says a hovercraft takes off from a platform and it's modeled by this. So 0 seconds have gone by because we just now start the equation because it's at 0 seconds. So you have two options, two ways to do this. You could do it by hand and plug in 0 for your x's and solve it, or you can do it on Desmos. I'm going to show you both ways, okay? So just so that we remember right now, actually we'll come back to that on Desmos. Let's try it by hand first, okay? So we have h of x equals negative times x minus 11 times x plus 3, okay? So we're going to plug in 0 for those x's because takeoff is just right when it bounces off that platform. So that's where you have to know, you have to think about these real world situations. Like if you were flying a hovercraft off of a platform and you were wanting to measure you're watching its pattern as it went, then you have to know you're going to start that pattern at 0 seconds right as you launch off the platform. Okay, so let's plug in 0. So I could say h of x equals negative times 0 minus 11 times x plus 3. Okay? So then I would just solve that down. Negative times 0 minus 11 is just negative 11 times, oops, I should have put a 0 there. Back. Plugging in zeros for x's, and I forgot. 0 plus 3. Okay, so we have negative times negative 11 times 0 plus 3 is positive 3. So then you multiply. Negative 1 times, well, what is negative 11 times 3? Negative 33. Which then that's just like a 1. Negative 1 times negative 33 is a positive 33. So it would have been at 33 meters. Okay? Now, let's check ourselves with some technology. Okay, so I'm going to stop share for a second on my iPad. Can somebody please write down this problem so that we can come back to it? I want you guys to know what we're looking at. So write down at least the say time of takeoff and write down h of x. Okay, so time of takeoff, we want to know its height. Okay, so as I'm moving this over, I want you guys to think for a second. Time of takeoff, x is 0. If we're going to look at a graph, what point on a graph is our time of takeoff or our x of 0? What special point on a graph? Okay, let's graph it and see if we can get there. All right, so here's the website that I'm going to give you guys the advice on these word problems to use. Okay, so desmos.com, desmos.com. And then we're just going to click start graphing. Okay, so now we're going to type in that equation. We're going to type in that equation into our graph. So we don't even have to write the h of x. It knows that already. We just need to type, negative x minus 11 times x plus 3. Enter. Okay, so it's graphed our function for us. Do you guys see this on my screen? You see this line? But look, I'm going to zoom out so I can see the whole thing. So you can just use your little screen. There's little buttons to zoom out over here, or you can use your mouse pad. Okay? So now I can see my whole parabola. Okay? So looking at this right here would be our, let me zoom in a little bit more. Okay, this right here would be our vertex, right? Okay. This right here would be our y-intercept. And then if I came down a little bit, there are x-intercepts. Okay, this is our vertex, or what we'd also call our maximum because it's opening down. Okay, so now I need to know, okay, so now that you see this, what might our takeoff time on the graph represent? What's the vocab word? You don't have to tell me the point. What's the vocab word of takeoff time or initial value? I'm gonna wait. A y-intercept, yes. Okay, y-intercepts. We literally just went over this right before we even got into these word problem or into the zero product properties. I said y-intercepts are your initial value. Okay, so like if I was throwing a ball off a roof, our y-intercept would be that 0 seconds right before it left my hand, and the height of the roof would be my initial value or my y-intercept. So in this problem, this point right here represents our takeoff time because x is 0, but our height, because that's what the problem asked for, if you remember, the problem asked for, locking my iPad, it said, what is the height of the hovercraft at the time of takeoff? Okay, so once you figured out the time of takeoff represented our y-intercept, then you would come over, you could go to here to Desmos and you could click and look what pops up right there. 0.33. It tells you your y-intercept. So when you click around Desmos, it tells you your special points. Okay, so you just have to figure out which one is it asking for. Was it asking for my y-intercept? Was it asking for my maximum or my minimum? Or was it asking for my x-intercepts? Okay, so Desmos can be really helpful and save you that math problem. But do you guys remember we just did this by hand and we got 33, right? So you have options on these. Yes, we did, thank you. Okay, so we did it by hand and got 33, so we were right. It is 33. You just have to know that the takeoff time is initial value. That's the hardest part about this, is remembering what pieces go together. Okay, so you can do it by hand every time if you want, but here's a good resource for you. Okay, so let's pop off Desmos and look at 2 other word problems and see if we can figure out how to put them into Desmos. Okay, so here's the next one. A certain company's main source of income is a mobile app. The company's annual profit in millions of dollars as a function of the app's price in dollars is modeled by P equals -2 times x minus 3 times x minus 11. What would be the company's profit if the app price is $0? Okay, so it says the company's annual profit, P, okay, so annual profit is modeled by the app's price in dollars. So X is our app's price. So this app price was X, is $0. Okay, app price is $0. Okay, so again, what has an X of 0? What would I look for if I were to graph this? You could plug in X of 0, but what if I were to go take this to Desmos, what should I look at? Type it in the chat. What should I look for? Ooh, I should have done that one. I'll talk about it. Again, X of 0. What would the company's profit be? Yeah, I need to look at the y-intercept. So if you want to plug it in by hand and go -2 times 0 minus 3 times 0 minus 11, cool, go for it. But if you want to just be able to graph it and if you know what you're talking about, that app price was X, and it says app price is 0, which means that would be our y-intercept, then you can go on to Desmos. So let's do that, okay? So I'm going to take this off and I'm going to say -2 times x minus 3 and x minus 11. Enter. Okay, so now I need to go find my y-intercept. So this one's a little bit different. So I need to move it around and I'm going to click somewhere. Oh, there it is. Okay, so if they price that app at $0, so this is how companies know what they have to price their app at. Okay, so if they price their app at $0, their profit is going to be -66. -66. They're in the hole $66 if they charged only $0. So then they would look at this graph and they might be like, okay, well, let's say that let's say that we evened out. They're like, okay, what could we charge the app? What would be the X value if we just bottom out? We didn't have any profit whatsoever. So the money it took to make the app, and then, or to buy the rights for the app, and we made it, how much would we have to make it to be able to just earn our profit back, not make money off of it? So that's what this point would tell us. They have to charge $3. They would have to charge $3, that X value, for them to get zero profit whatsoever. So for them to not go in the hole and for them to not gain any money from it. Are you guys following this? What do you guys think? So this is really, if you're a business mind, or if you, like, I know some of you have been like, no, Miss Bill, I got business ideas, and I'm gonna, I'm gonna have the big money one day, I'm gonna be my own boss. Okay, well then you better know these things, because here's the thing, here's how you know, looking at a quadratic equation, if this company wanted to know what can we charge the app, what's the price of the app that we make the maximum amount of money off of this? Well, that's what this point is right here. Okay, if that app was $7, that better be a good app, so all I gotta say if I'm paying $7. But anyway, that app is $7, then they're gonna make a $32 profit off of that, with just that sale. Okay, and then it would grow from there depending on the number of sales. Okay, so this is why quadratic functions are useful. Okay, so let's actually, I'm gonna put back in that equation that we did the platform one, and I want us to talk about something else on that might, okay, so let me real fast put that last one back up. Remember, this was us launching a hovercraft off a platform. Okay, remember we got here and we said that its initial height would have been 33. But what if I said, how many seconds after takeoff will the hovercraft hit the ground? What would the height be? I want you guys to chat to me. What would the height of a hovercraft be when it hit the ground? What would its height be if it hit the ground? Yep, 0. The height would be 0. So we're gonna look at where our y is 0. So that means we're looking at our x-intercepts. Okay, so now we wanna see how many seconds. Well, here's one of them. Can seconds be negative? No, time cannot be negative. So then we're looking at this one right here. So this was the path of our hovercraft. At 0 seconds, it was 33 feet off the ground. It went shoo, 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 hit the ground, okay? So it hit the ground at 11 seconds, okay? So you have to know what it's asking you for. It's asking you for the x-intercepts. So it's asking for the y-intercept. It's asking for a maximum or a minimum. Are there any questions on that problem or the profit problem before we try one of the maximum minimum ones? And then I'm done. Got anything? Again, if you want to put these in by hand, by all means, go for it. Because for this one, you would just put you would do the zero product property if you were to do these by hand. But Desmos is really easy. Guillermo is a professional deep water free diver. His altitude in meters relative to sea level, x seconds after diving, is modeled by g of x equals 1/20th x times x minus 100. What is the lowest altitude Guillermo, I cannot talk today with my not feeling good, will he reach? Okay, so lowest altitude. So we could say, what is the maximum amount of money that they could make off that app? Or like in this case, it says lowest. So when you see the word lowest, I hope you think minimum. Okay, I hope you think minimum. Okay, so it says that we are looking at his altitude is modeled by this, so that, and then x seconds after diving. Okay, so if it's minimum, we would have to find our vertex from that, looking just like that. We'd have to find our vertex. I don't really want to try to have to find the vertex of that. and I like math. Okay, so I have a feeling you guys don't either. So that's where we pop on over to Desmos, okay? So I'm gonna erase this and I'm gonna put 1/20th x times x minus 100. Ooh, that's really big. Okay, so again, we have our y-intercept would be when he first took off and went under the water. So here that 0, 0, he was at sea level, he dove into the water, and so now he's going down, 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 and it said, what is the lowest altitude that he hit? And we have to remember altitude was our y values. Maximum minimum is talking about our y values, okay? And then x seconds. So he hit that, we go down to the vertex, he hit negative 125 feet, no, meters, sorry, negative 125 meters. And then if it said when, seconds, when did he hit, it doesn't in this problem, but it could after that, if it was 2 parts. If it said when did he hit the lowest altitude, then it would be 50 seconds. Okay, but the lowest altitude is that y value of negative 125. So this one, you didn't even have to do anything by hand if you knew that lowest, minimum, and minimum is your y value, and you know how to use Desmos.